In previous lessons, we've seen how we can use conversion factors with a top and a bottom to convert units like kilometers to miles. But what do we do when the thing that we want to convert, the thing that we want to start with, already has a top and a bottom, like kilometers per hour? How do we use conversion factors then? That's what we're going to talk about in this video. A car is driving at 105 kilometers per hour. What is the speed in miles per hour? So the units here in kilometers per hour, they're part of a fraction. They have a top and a bottom. Sometimes that's not apparent by how it's written here. So something that we're going to want to do is take it and expand it out. So 105 kilometers, that's on the top, and then we have a slash. There's a fraction, and then hours is on the bottom. Okay, so we're starting with something that has a top and a bottom. What is the speed in miles per hour? So what we want to do is we're going to want to go from kilometers per hour to miles per hour. So we're going from kilometers to miles. In order to do this conversion, I need to find a relationship between kilometers and miles. You can look it up somewhere and you'll find this relationship here. I want to write this as a conversion factor to get rid of kilometers on here and put miles instead. So here's our conversion factor setup. Kilometers is up here, so I want to put kilometers down here so they cancel out. So this part of the expression is going to go on the bottom, 1.609 kilometers. And now miles, 1 mile, is going to be on the top. Now here's what happens when the units cancel. This is important. Kilometers is up here, and kilometers is down here. So they both cancel. But we are left with 2 units, not just 1. We're left with miles up here and hours down here, and both of these 2 units will make up the units for my final answer. I'm not going to go through the math because I've talked about that in previous videos, but whenever you have something on the bottom of a fraction that doesn't have any numbers on it, when it's just kilometers per hour, you can always write in 1 here. It's really 105 kilometers over 1 hour. Okay, so anyway, you can do 105 divided by 1 times 1 divided by 1.609. And the answer that you'll get is 65.3. And the units here, we're keeping miles and it's on the top. And we're keeping hours and it's on the bottom. And check that out. This is exactly what we wanted. We wanted miles per hour, miles on top, hours on the bottom. So that's how you can do these with a top and a bottom. Let's do a couple more. The density of gold is 19.3 grams per cubic centimeter. That's the same as centimeters cubed. What is this in ounces per cubic inches? So 19.3, the density of gold, has a top and a bottom. The first thing I want to do is write it with a top and a bottom. So 19.3 grams divided by centimeters cubed. And as I said before, if there are no numbers here, you can always put a 1 there, divided by 1 centimeter cubed. Now, I have grams, that's my unit of mass, and I'm going to convert that to ounces. So I want to go from grams to ounces, and I also want to go from cubic centimeters into cubic inches. So I'll need conversion factors that are going to let me go from grams to ounces, and they can be based on this relationship here, grams and ounces. And I'll also need an expression that tells me about the relationship between cubic inches, right here, and cubic centimeters. Now I can turn these 2 statements into conversion factors. But we're going to have to go one at a time, and then I'll show you how we put them together at the end. So the first thing let's do is let's get rid of grams here. So I'll use this expression to put 28.35 grams on the bottom, so they'll cancel out. And then I will put 1 ounce on the top. So now grams and grams cancel out, and I'm left with ounces, and that's good because ounces is one of the units that I want. So I'll circle that to show that we're going to keep it. But now there is cubic centimeters on the bottom here, and we still haven't gotten rid of it. So I'm going to add another conversion factor in here, multiply by a 3rd conversion factor to get rid of cubic centimeters. Now cubic centimeters is on the bottom here, so I'm going to want cubic centimeters on the top over here. Sometimes people ask, wait, but if I have cubic centimeters over here, is it going to cancel out cubic centimeters all the way over here? Absolutely. as long as all the conversion factors are multiplied together in a row. It doesn't matter where they are in the row of multiplied conversion factors. All it matters is that one is on the bottom and one is on the top, and they will cancel out no matter how far away from each other they are. Okay, so cubic centimeters on the bottom here, I'm going to put 16.39 cubic centimeters on the top over here, and then I'm going to have 1 cubic inch on the bottom here. So from all the way away, cubic centimeters up here are going to cancel out cubic centimeters down here, and I'm left with inches on the bottom. I'm sorry, cubic inches on the bottom. Oh, I wouldn't want to screw that up. So now I have ounces on the top, cubic inches on the bottom, and that's perfect because I want ounces over cubic inches. So I'm going to do this divided by this, times this divided by this, times this divided by this, and the answer is 11.2 units, ounces on the top, cubic inches on the bottom, and there we go. A gourmet chocolate sells for $2.50 per ounce in the US. This is making me hungry. You want to sell it in bulk in Japan. What will it cost in yen, that's a currency in Japan, per kilogram? And obviously Japan uses a metric system, so they're going to be weighing it in kilograms. So what we're starting with is $2.50. I'm going to do USD. That's US dollars just because it's easier to use as a unit. $2.50 USD per ounce, or we can say per 1 ounce. We want to go from US dollars to Japanese yen, JPY. That's one conversion that we want to do. And then the other conversion that we want to do is we want to go from ounces here, we want to go to kilograms. Let's look at what expressions we can find that tell us how these units relate. So, as you probably know, the exchange rate changes daily, but on the day that I'm doing the video, on the day that I'm doing this video here, 1 US dollar equals this many Japanese yen, so we'll just use it. Now, for ounces to kilograms, let's say that you look at a chart of conversion factors and you can't find one that goes from ounces to kilograms. Instead, all you can find is one that tells you ounces to pounds, okay? And then the other one is pounds to kilograms. Now, this isn't the worst thing in the world, but what we're going to have to do is, in order to get from ounces to kilograms, we're going to have to go through pounds and then go from pounds to kilograms. So this is going to become 2 steps instead of just 1. Anyway, we're starting with this. So the first thing let's do is let's get rid of US dollars. I'll use this expression to put US dollars, one of them on the bottom, and I'll put 77.4 Japanese yen on the top. So now US dollars cancel, Japanese yen ends up on the top, and I'm going to circle it because we want to keep it, because that's what we want on the top. Now, we have ounces on the bottom, we want to turn it into kilograms, so the first thing we got to do is we got to multiply it by something just to get rid of it and get us into pounds. So I'll use this expression here. Ounces is on the bottom, so I want 16 ounces here, I'm getting it from there, to be on the top. Now we'll cancel, and then 1 pound is going to be on the bottom. So ounces cancel there, ounces cancel up here. Now I'm left with pounds. To get from pounds to kilograms, I'll use a unit, I'll use a conversion factor that has units of 2.20 pounds on the top, so they cancel here. And I'll put 1 kilogram here on the bottom. So pounds on the bottom, pounds on the top, and now that leaves me with kilograms. So I have Japanese yen on the top, kilograms on the bottom. Plug through the math, this divided by this times this divided by this times this divided by this times this divided by this equals 6,810 Japanese yen, JPY, per kilogram. And that's that. I'll do one more if you want the practice, but I'll do it fast. What is 25 miles per hour expressed in meters per second? So we're starting here with 25 miles per hour. And for this expression here, we want to go from miles to meters, and we want to go from hours to seconds. let's assume that you went to your table of conversion factors, or your table of these equivalences, and these were the only ones you could find. You got from miles to kilometers, and then kilometers to meters, and then hours to minutes, and minutes to seconds. So the point is we can't go straight to either one of these destinations. We've got to go from miles to kilometers, and then from kilometers we can go to meters. And then for hours to seconds, we can't go directly there. We can go from hours to minutes, and then minutes to seconds. I've already written out these conversion factors, so we can go really fast. So here's 25 miles per hour. I'm going to multiply that by something to get rid of miles. So here is my kilometer conversion factor. Miles up here, miles down there, they cancel out. Now I will multiply this by something to get rid of the kilometers. So I have this expression written as a conversion factor. Kilometers up, kilometers down, they cancel out. Now I have meters, and that is good. Meters is good because meters is one of the units that I want. Okay, so I'll circle it to keep it. We still have this hours over here that we got to get rid of. So the first thing I'll do is I'll multiply by this, hours down here, hours up here. Everything's multiplied together though, so no matter how far away they are, they still cancel out. Hours up, hours down. Now I got minutes, and I need to take that to seconds, so I will add this conversion factor at the very end. Minutes down here, minutes up there, and seconds down there. So the two units that I'm left with are meters over seconds, and that's good. This divided by this times 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 this divided by this gives me 11 meters per second. I wrote it like this with a slash, but you might want to think about it written like 11 meters per second, just so the top and the bottom of the fraction are a little bit clearer there. Okay, so anyway, that's how you do these conversions with a top and a bottom. Just remember that you're going to have two units probably that you got to convert, no matter how far apart units are. If you have a whole bunch of conversion factors multiplied together, if one's on the top and the other's on the bottom, they will absolutely cancel out no matter how far away they are.